We're going to talk about a simple trick for figuring out R&S when our number 4 substituent is not in the back. Not in the back. Okay, so remember when we're figuring out R&S, we have to have first of all, you have to have a stereo center, right? And the stereo center, it has no two groups attached to it which are identical. So CH3, BR, HCl, these are all different. So this is what makes this a stereo center, 4 different groups. And when we're figuring out R and S, remember we rank the different groups that are attached to our central carbon according to their atomic number. So in the case of our atom here, we've got carbon attached to bromine, carbon, chlorine, hydrogen. If you look on the periodic table and you rank them according to atomic number, bromine's number 1. Then right above it in the periodic table is chlorine, and then above it and a little to the left is carbon, and then hydrogen is the last. It's the smallest of the 4, okay? And then remember that when we're figuring out R and S, we always put number 4 in the back. Always put number 4 in the back. Now, number 4 is in the front at this point. Number 4 is a wedge. So how do we figure out R and S even though H is a wedge? Okay, so there's a long way to do this, and there's a short way to do this. So first of all, okay, the long way, just what would we do if we needed to put H in the back? Well, we'd have to rotate. So if we rotate, what we would do is we'd keep one of these bonds the same, and we want to move hydrogen to the back. So let's show how we would do that. Let's say we keep chlorine, carbon, this bond is exactly the same, and just like a steering wheel, we rotate each of these 3 groups. And what would this atom look like? Well, now we've got the molecule look like. We've got carbon, and now we'd have our bromine is going to be down there. So we can redraw everything the same. Redraw everything the same in terms of like the wedge, the dash, and the thing that's in the plane of the page. Now, your hydrogen is moving from the wedge to the dash. So your hydrogen is going to be there. Your bromine's moving from the dash to the straight line. So your bromine's going to be here. And your CH3 is moving from the straight line to the wedge. So CH3 is going to be here. Now we can figure out R and S because we've put the hydrogen in the back. Put hydrogen in the back. So this is number 4. This is 1, 2, 3. So when we do that, we trace a line between 1, 2, and 3. We see that it goes clockwise. So 1, 2, 3, like so. Okay, so clockwise. So it is R. It's R. Now, that's the long way to rotate. You won't always be able to rotate a bond. It's not always the easiest. So there's actually a much faster way to figure out whether it's R or S in a situation like this instead of bond rotation. So here's what we're going to do. So what you just do is let's redraw this because it's actually kind of crowded here. Chlorine, CH3, put the hydrogen as a wedge, and put the bromine, Br. Okay, so you're going to rank them as before, right? This is number 1, this is number 2, this is number 3, this is number 4. So what you just do is you pretend number 4, you just ignore group number 4, that you ignore the fact that it's a wedge for the moment. And you trace a line like you normally would. And it goes, in this case, it goes counterclockwise, right? So it's going counterclockwise. And ordinarily, that would be S, right? It would be S if it went counterclockwise. But H is in the front. So here's what you just do. You just flip the direction. So instead of going counterclockwise, just imagine that it's just going clockwise instead. So flip it from counterclockwise to clockwise, and this gives you R. So basically, bottom line is, if you see your number 4 is in the front, it's a wedge, just do your priorities like you normally would, 1, 2, 3, 4. Ignore number 4 for a moment, and then trace a line between 1, 2, and 3. And if it's telling you S, then you know it's going to be R. If it told us R, it would be S. And it's really straightforward. Once you get into it, see that it saves you a lot of time, and you won't do all these bond rotations, which it's easy to make mistakes. This is a very simple example. Looks like an easy bond rotation, but you'll see there's a lot of examples where bond rotations are a little bit more difficult than this, so they can be tricky. So that's it. Just simple rule. If H is